Algebra students, we are going to continue our study of polynomials. So we've talked about exponent rules, and you need to know all those. So review those, all those exponent rules. Those exponent rules, if you look closely, apply to things that are being multiplied only, multiplied and divided. So we're going to talk about polynomials. So some things here you can read about. Polynomials are made up of terms, and terms are the product of numbers and or variables, so that's what we've been working with, just one term. That one term is called a monomial. If we had two terms, it's called a binomial. Notice these two terms are separated by subtraction. Trinomial has three terms, so ax squared plus bx plus c, those three terms, and they're not like terms, can't be simplified anymore. So when we say polynomial, we mean all those things, monomials, binomials, trinomials, and more. Everything is a polynomial when they look like that. So take a look at this example. One of the things we do with polynomials is... sorry, dog is distracting me. Break, go on. So one of the things we do with polynomials is we will substitute a value of x into this polynomial. So here, when we get something like 2x squared minus 4x plus 6, evaluate the expression when x equals negative 4. What we'll do is we'll say, all right, I'm just going to replace x with negative 4 in parentheses. And I can't stress the value of putting in parentheses. So now when I begin to simplify this, I end up getting negative 4 times negative 4, and that is positive 16. I get minus 4 times negative 4, so that becomes minus a negative 16, and then plus 6. So I end up getting 32 plus 16 plus 6, that's 48 plus 6, or 54. So that is the value of this quadratic trinomial. So that's a fancy term for what this is. It's just a polynomial. We'll get into the vocab of why I know it's a quadratic trinomial later. But if we evaluate that polynomial when x equals negative 4, we get positive 54. Try this next example on your own. Pause the video and try that. Okay, same idea. Replacing everything with negative 4 in parentheses. So I get negative 4 cubed minus negative 4 squared plus 6 times negative 4 minus 21. Negative 4 times negative 4 times negative 4. So that ends up being, if you write it out, this. Do you see how I get a negative times a negative times a negative times a negative, which is positive? 4 times 4 times 4 is 64. Minus a negative 4 times a negative 4, which is 16. So minus 16 plus a negative times a positive is a negative, so negative 24. So minus 24 and then minus 21. All right, so 64 minus 24 is 40. 40 minus 21 is 19. 19 minus 16 is 3. And there's your final answer. The other thing we do with polynomials, or that we're going to practice with polynomials right now, is just adding and subtracting polynomials. When we add and subtract polynomials, all we're doing is collecting like terms. So when you get a problem like this, I like to look at in each parenthesis we're adding, so I really don't even need the parentheses. And I look here and I have a 4x cubed and I have a 3x cubed. And then I look and I have a negative 2x and I don't have any other x's. And then I look and I have a negative 9x squared and I don't have any other x squareds. And then the last thing I see is an 8 and a negative 11. And so you don't have to rewrite it this way, but you can, because it is addition, we can rearrange the order however we like. And sometimes it's nice to just put all the terms together before you have to do anything with them and see how we just add these like terms. 4x squared plus, 4x cubed plus 3x cubed is 7x cubed. There are no other x squared, so the answer is minus 9x squared. There are no other x's, so minus 2x. And then these constants here, that would be negative 3. Now, I also did something in that process that you may not have thought to do, and I wrote it so that the x cubed term was first, followed by the x squared term, followed by the x term, and then lastly the constant. Most kids don't think of the constant this way, but remember, anything to the 0 power is 1, and this right here, this is an x to the first power. And so if you look at the powers right now, they go 3, 2, 1, 0. And we call that descending order. And is that a C there or not? It might be a C, descending. Yeah, I don't know. We'll just write it like that because, I can't spell. I'll have to look that up. But descending order is a way we express a lot of polynomials, and if we always write our polynomials in descending order, we'll always have the same answers. You, me, the back of the book, things like that. So that's one of the reasons why we do it, to standardize answers. So try this example on your own. This one's a little more complicated. We've got addition and subtraction, so try to give this one your best shot. Okay. You don't really have to worry about the first two parentheses because there's no numbers out front and it's all addition. It's this last one where you have to change the sign of everything. If we're going to subtract this whole thing, I'm going to end up getting a minus x squared, a plus 9x, and a minus 8. Now, once I've taken care of that minus sign, now I can just kind of group like terms as we go. So I'm going to use some different colors here. I've got a 2x squared, I've got a 5x squared, and I've got a negative x squared. Getting those together, that's 7x squared minus x squared, that's 6x squared. Next thing I see is I have a minus 4x, a minus 6x, and a plus 9x. Minus 4x minus 6x is negative 10x, plus 9x, that's a plus negative 1x, so I could have just said minus x. And then lastly, the constants. I have a 3, a 1, and a negative 8. 3 plus 1 is 4. 4 minus 8 is negative 4. And there's your final answer. 6x squared minus x minus 4. So that's what we're working on in class. Adding and subtracting polynomials by collecting like terms. Evaluating polynomials by subbing in numbers for them in parentheses. Remember, polynomial is a fancy word to just mean many terms that are separated by addition and subtraction, and those terms are multiplying and dividing numbers and or variables. I know. That's why the vocab is so important, because polynomial expresses a very simple idea, but an idea that takes a lot of words to describe without the word. So, anyway, guys, have a great night. Thanks for watching. Peace.